Math 7, Unit 7, Lesson 6.2, Compound Probability. This is the second part. We learned about the fundamental counting principle last time. From last lesson, remember the set of all possible outcomes of one or more events is called the sample space. You can use the tables or tree diagrams to find the sample space of two or more events. In a table, it works well for two events. You can see along the x-axis here, I've put event 1 that can happen three ways. Along the y-axis of the table, I have put that event 2 can happen two ways. That gives us 6 different options here. The tree diagram, you can also see 3 ways for event 1, 2 ways for event 2. But this right here is the sample space, and you're going to have to create sample spaces today to calculate probabilities. This was covered in a previous video. I'm going to link that here and then just quickly go through this, emphasizing the fundamental counting principle. If you flip 2 coins, there are 2 outcomes for the first coin, 2 outcomes for the second coin, total of 4 outcomes. If you flip a coin and toss a number cube, there are 2 options for the coin and 6 options or outcomes for the number cube, giving a total of 12 possible outcomes. This right here is the sample space. Number 3. On this one we had 5 different ice cream flavors, 3 different sauces, and 4 different toppings, giving us 6 different outcomes, 60 different outcomes, or 60 different sundaes. Number 4, there were 5 different colors of Ranger. There were 2 transmissions, 2 drivetrains, and 2 cabs, giving us 40 total outcome possibilities for this Ford Ranger. Okay. I can count outcomes of compound events, make sample spaces, and calculate compound probability. So we're going to be doing those things. Counting the outcomes, that's fundamental counting principle. Making a sample space takes a little more time, and calculating compound probability, you're going to use the sample space today to do that. The set of all possible outcomes for one or more events is called a sample space. For example, the sample space for flipping 2 coins is heads heads, heads tails, tails heads, and tails tails. When 2 or more events are considered together, we call it a compound event. For example, flip a coin and roll a number cube. That was one of the examples from last time. The probability of a compound event is the same as for simple probability. The probability of the events is the number of favorable outcomes divided by the number of total outcomes. And then the fundamental counting principle, FCP, can be used to determine the number of outcomes for compound events. You use the fundamental counting principle by multiplying the number of outcomes for each sub-event together to get a combined number of outcomes for the compound event. Example, rolling a number cube 3 times has 216 outcomes. That's 6 outcomes for each number cube, and 3 of them, 6 times 6 times 6, that'll give you 216. You randomly choose a crust and style of pizza. Find the sample space. How many different pizzas are possible? Alright, first it says to find the sample space. Right here you can see a tree diagram. We've got thin or stuffed crust, and each of those branches out into Hawaiian, Mexican, pepperoni, or veggie. This gives us, this is our sample space. Thin crust Hawaiian, thin crust Mexican, thin crust pepperoni, thin crust veggie, stuffed crust Hawaiian, stuffed crust Mexican, stuffed crust pepperoni, and stuffed crust veggie. That is our sample space. The second part asked how many different pizzas. There are 8 different pizzas possible, and we actually had to list them because it asked for the sample space. If it asks for sample space, it's a list. If it asks for number of outcomes, it can just be a number. Find the total number of possible outcomes for rolling a number cube. Method 1 is to make the sample space and then count those up. So here you can see 2 coins and 6 die rolls. That gives us a total of 12 outcomes. Method 2 is to use the fundamental counting principle. There are 6 ways event 1 can happen, rolling the number cube. There are 2 ways event 2 can happen. This gives us a total of 12 outcomes using the fundamental counting principle. If it's just asking for a number of outcomes, fundamental counting principle is king or queen of being able to find it quickly. The sample space you do need to sometimes be able to come up with. How many different outfits can you make from t-shirts, jeans, and shoes in the closet? Now here it's just asking how many. We don't have to make a list. So we're just going to use fundamental counting principle. Event 1, choosing a t-shirt, has 7 possibilities. Looks like dark yellow, light purple, orange, blue, green, and black. There are 7 outcomes. Choosing jeans has 4. Looks like we've got green, dark yellow, black, and blue jeans. And then choosing a pair of shoes has 3 outcomes. You can see along the bottom of the closet there. If we multiply those all together, we do get 84 different outfits. So the outcomes here are outfits. Number 2, find the total number of possible outcomes of spinning the spinner and choosing a number from 1 to 5. Okay, spinning the spinner has 4 outcomes. Oh, I don't write the number 4 several times. And spinning 1 through 5. So 4 outcomes on the spinner, 5 outcomes on picking a number. That's 20 outcomes total. How many different outfits can you make from 4 t-shirts, 5 pairs of jeans, and 5 pairs of shoes? Okay, when we pick the t-shirt, there are 4 outcomes. When you pick a pair of jeans, there are 5, and pair of shoes, there are 5. That gives us 100 total outfits. 100 outfits or outcomes. How many different sports jersey numbers are possible if they can be 2-digit numbers using only the digits 0 through 5? All right, so the 2 events here, event 1 is the first digit, and event 2 is the second digit. Now, in some sports, they restrict the numbers on the jerseys to being less than 5. That's because the referee generally has 2 hands, and on one hand they can hold up the number of fingers for the first digit, and on the other hand they can hold up the number of fingers for the second digit. And if you had numbers bigger than 6 or bigger, you wouldn't be able to do it on one hand. And 0, that would just be holding a fist with no fingers up. So it does have definite advantage. Now the first digit can happen 6 ways. Those numbers are 0, 1, 2, 3, 4, 5, or 5. That's 6 different numbers. And the second digit can happen 6 ways. This gives us a total of 36 jerseys. 36 jerseys. In example 2, what's the probability of rolling a number greater than 4 and flipping tails? Let's go back to example 2. A number greater than 4 and tails. Well, here's the only ones that actually are greater than 4 and tails are 5 tails and 6 tails. So there are 2 favorable outcomes in the sample space for rolling a number greater than 4 and flipping tails. It's 5t and 6t. So it is 2 out of 12, which does reduce down to 1/6. The probability of getting a number greater than 4 and tails is 1 out of 6. Find the probability of the compound event. You flip 3 nickels. What's the probability of flipping 2 heads and 1 tails? All right, we are going to have to do a sample space here. We can get heads or tails with the first nickel, heads or tails with the second nickel. The third nickel can also come up heads or tails. Oh, I've missed one here. Got to be careful when making these that you don't get things too close together. Okay, and then the third one is heads or tails, heads or tails, heads or tails. Okay, so my sample space, if I go up this row, that's heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, tails, head, tails, tails, heads, and tails, tails, tails. We should end up with, since it's 2 times 2 times 2, we should end up with 8 outcomes in our list. And 1, 2, 3, 4, 5, 6, 7, 8. We do have all the outcomes. Now, back to the original thing, we want to know the probability of getting 2 heads and 1 tails. So that's 3 heads, that won't work. This is heads, heads, tails. That's 2 heads and a tail, 2 heads and a tail. All the others are not 2 heads and a tail. So the probability here of getting 2 heads and a tail is 3 out of 8. 3 out of 8. Here we had to make a sample space and use that to calculate the probability. Find the probability of rolling 3 6-sided dice so that you end up with triples. All 3 are the same number for triples. Well, first, a sample space for this particular event would be a list of 216 different outcomes. That is quite the list, and if you get started with it, it's going to go on for a very long time, because you can get 1, 1, and 1, 1, 1, and 2, 1, 1, and 3, etc. 216 of these. Now, I don't recommend trying to make that list. There's got to be a better way. Well, we would need the list to know on the probability what the total number of outcomes. We know the total number of outcomes. If we can figure out how many favorable outcomes there are, maybe we just list those. And we can. There are only a certain number of them. Here's the first one that would work. 1, 1, and 1. There are a few more. We could get 2, 2, and 2. 3, 3, and 3. 4, 4, and 4. 5, 5, and 5. And 6, 6, and 6. There are a total of 6 outcomes that are triples. And there's 216 outcomes in the sample space. We don't really want to make that list. That would be rather time consuming for not much benefit. Anyway, this reduces down to 1/36. Your probability of getting triples is 1 out of 36, so it's actually quite unlikely. But if you sit down with 3 dice and roll them, you will end up getting triples a few times, depending on how many times you roll. Find the probability of 2 heads and green on the spinner shown. Okay. Couple ways we can look at this. We got to think about the sample space. How many are in it? There are 2, 2, and 4. There are 16 total options in the sample space. Now 16 is not a very big number. We could list this, but maybe we can get our way around having to list it. How many ways can heads, heads, and green happen? Heads, heads, green. Well, I think there's only one of those. That would only be one branch of the tree. So there are 16 total outcomes, only one of which is heads, heads, and green, giving us a probability of 1/16. Yeah, because you'd have heads, heads, green, heads, tails, green, tails, heads, green, and tails, tails, green. Those are all the ones with green. Everything else wouldn't have green in it. Now, of those that had green, only one of them was heads, heads, green. So this will be 1 out of 16. All right, in your assignment, on number 1, you're going to use the fundamental counting principle to find the total number of possible outcomes. Just count up for each separate event and multiply how many options there are for each to get the total. Number 2, you're going to spin a spinner and flip a coin, determine the probability of each compound event. You are going to want to start by making a sample space here. The sample space is not very large here because there are only heads or tails, and you can get it with 1, you can get it with 2, all the way up to 5. So there's not very many in this list. Just make a list of the sample space and then calculate these probabilities. Number 3 is a review of proportional reasoning. 4 is a review of solving equations. Number 5, review of finding volume. Number 6, a review of percent problems and proportion. 7 is you're going to draw a couple of tree diagrams so that you can find the sample space of each. And on number 7, you will answer with a list of outcomes, the sample space. Number 6 is about security codes. Now, if you've got a good security code, you want a lot of possible outcomes, so it is not easy to guess. Thanks for watching.